Hello everyone, my name is Lazaro Liatsas. I'm a research engineer and a Marie Curie doctoral candidate from nearby commuting. Today, I will try to give you some insights on my PhD research that has the main theme of keeping health services running smoothly in a connected world. To start things off, I would like to present you ELIXIRION, a Marie Curie doctoral network project under which I am doing my PhD. 8 different countries and 14 different institutions from academia and industry host 10 doctoral candidate programs, each of them pursuing research on topics relevant to Healthcare 4.0, utilizing technologies such as 6G networks, edge computing, and other state-of-the-art technologies with the vision of a connected, robust, and reliable healthcare. I would like to start off with a couple of words about Healthcare 4.0. Healthcare 4.0 envisions a world where your health is monitored and managed in real time, exploiting the latest technologies to allow data to be processed quickly and securely, even outside traditional hospital settings. It is the application of Industry 4.0 principles to healthcare, integrating advanced technologies to deliver smarter, more personalized, and connected health services. To achieve this, it utilizes the latest technology advancements, such as 6G networks and what we call Internet of Things, artificial intelligence and big data analytics, as well as cloud and edge computing. These technologies unlock the possibility of having applications such as remote patient monitoring or even remote surgery through robotics, applications that otherwise would be impossible to handle. And these are only two examples of the great potential of Healthcare 4.0. In order to get a bit more onto the specifics of my research topic, which is service and network management for healthcare applications, it is important to highlight some of the challenges that surface from this complex environment of interconnected devices, from wearable sensors to cloud servers. Network fluctuations causing from high latency to complete network disconnections, device failures, and even security breaches of data that are highly sensitive, such as medical personal data, makes service monitoring and coordination crucial, especially for the case of healthcare where the criticality of this application is enormous, with severe consequences of things possibly going wrong. Therefore, there are three main goals when it comes to service network management: enforcing service continuity, minimizing communication latency, and finally guaranteeing the privacy and security of the data. This brings us to service orchestration, the process of managing, running applications by configuring network and infrastructure settings to guarantee their smooth functioning, minimizing risks of latency and failures, as well as optimizing cost in terms of resources and energy. To achieve that, we utilize a feedback system that is also known as a closed-loop orchestration system that has artificial intelligence on its center. Through monitoring of the applications and their underlying infrastructure, we collect big amounts of data, relevant data, from either running applications, connected servers, sensors, and whatever is available. All this data is then processed by analytics, utilizing AI to gather insights of the current status of the system, which could be a degradation of performance of a single application or more, and or maybe some kind of bottleneck in the network. And then these insights can also help to predict future incidents such as fluctuations and failures in system devices or applications. All this data After the analysis, the produced insights are used for the decision making regarding needed changes to the system. Sometimes specific services need to be moved to other devices. Some services require more resources to be allocated to them, or change where the incoming traffic is being forwarded, depending on either the current workload or predicted forecasted workload. These changes are then applied through an orchestration platform connected to the infrastructure to close this feedback loop. This gives us a system that can self-adapt to environment changes and proactively act to keep everything running smoothly. Finally, a big focus point of my research is about the interpretability of the AI models used both in the analysis and the decision-making part of the previously mentioned loop. AI has been gathering a lot of attention lately, and rightfully so. There is this huge AI hype with LLMs. Everyone knows ChatGPT nowadays, and it has already proven its performance in numerous of applications and a variety of fields. An important limitation, though, has to do with our ability to completely comprehend the thought process of the systems and explain their outputs. Explainable AI is an advancing field targeting this exact limitation. It aims to provide trust and reliability for the end user of the system, taking also into account ethics, security, and privacy. More significant for my line of research, it is a very helpful tool for the system designers and engineers also, as interpreting the model's behavior can enable us to troubleshoot mistakes, design better, less complex models, and to integrate these explanations to the decision-making process itself. In a field with applications so critical like health services, being capable to fully interpret an AI model's decision can act as a requirement towards its applicability. This was my presentation on the vision of a connected and smart healthcare with reliable, explainable intelligent systems at its core. Thank you for your attendance. If you found this presentation and my research interesting, you can always reach out to me through my email or visit the ELIXIRION website to get more information on the advancements of this project.